All right, everyone, welcome to our week 8 live classroom. I forgot to start the recording. We didn't have any questions about week 7. So let's go ahead and dive into week 8. So week 8 will build a little bit on the concepts that you learned last week when we were learning about logic. Okay, and I say that because when you deal with repetition, you deal with logic. All right, if I was going to say, if something is true, I'll do this. Otherwise, I'll do something else. Repetition is formed in a very similar way. I could say, if a certain condition is true, I will repeat a certain chunk of code, all right? And the way I check for those conditions in repetition is the exact same way that I would do it for an if statement, okay? So what is repetition? It allows the developer or the program to execute the same code multiple times. Okay, and like I said, this always includes a Boolean condition, similar to like what you're used to with the if statements. In JavaScript, while and for loops are extremely common. Okay, these are pre-test loops, which means that the content of code inside of the loop will run if the condition is true. Okay, it checks for that test beforehand, so we call it a pre-test loop. There is a post-test loop where the code inside the loop will execute once, and then at the bottom of it, it will check a condition to see if it should jump back up and repeat. Okay, those exist in every programming language that I am aware of, but they are not as commonly used. All right, there are a number of different ways to control loops. Okay, looking at the just control structure. So JavaScript has 4 different types of loops. There's a while, a for each loop, and a do while loop. Okay, and this do while is the only post-test loop that exists in JavaScript. So let's look at the while loop. Now notice these parentheses right here. Okay, if I didn't have while right here, I could have if, and this statement would work just fine. And if x was less than 5, then I would alert x. Okay, but instead I have a while loop here. So it says while x is less than 5, alert x. And then in addition to that, I say I'm going to increment x. So x was declared at 0 at first. Then the first time we loop through, it'll bump up to 1, and then 2, and then 3, and then 4. And then once x is equal to 5, it's no longer less than 5, and so it'll jump out of my loop. And so it'll run this code 5 times. And I can test that out. If I pull up, let me just pull up a program here. So I'm calling a function called sumOdd, which doesn't really matter for the purposes of this. But if I said while x is less than 5, then I'm going to say alert x, and then x plus plus. Okay, I need to say var x equals 0, so that I declare that. And then I'm going to copy the file path and run it. Okay, so I'm going to open up my developer tools so I can see what's going on here. And I'm going to put a breakpoint right here inside of my function that I'm about to call. Okay, so I didn't care about anything else going on the page. I don't care about the input. X is equal to 0. So I can highlight this and be like, okay, is x less than 5? Yes, that's true. I can hit F10 to go to my next step. And I'll say, okay, well, let's go ahead and alert x. It says, oh, the page says 0. Okay, so I'll say, okay, the code keeps on running. X plus plus, we'll just add 1 to x. So now x is equal to 1, which if I highlight over this, I can see, yes, that's true. It's still less than 5. And it'll alert x again as 1. Okay, and then it'll keep going. Now it's 2, 3, 4, and then it finishes. Okay, any questions about this example? Okay, well then let's keep going. All right, this is a very standard counting loop. Okay, x is equal to 0, while x is less than 5, I will increment x by 1, so I could guess that that'll be executed about 5 times. Okay, this, however, is a sentinel controlled loop. Okay, which means that it isn't dependent on a single variable alone. Or if it is dependent on a single variable alone, that isn't controlling the amount of times that we're looping through. So you can see here, I'm going to loop through while sum is less than 5. I'll add x onto sum, which will increment sum, but x is the one that's basically counting up from 0, okay? And then as we count this, we'll just add x onto sum. And so looking at this at a glance, I don't know exactly how many times this would execute, okay? I'd have to think. I'd be like, okay, x is 0, so sum would be 0. X is 1, so sum would be 1. X is 2, so sum would be 3. X is 3, so sum would be 6. You know, and I'd have to think through that. But let's go ahead and run that. And I'll show you guys something kind of cool that you can do. So I'm going to say, well, sum is less than 5. I'll also say var sum equals 0. Well, sum is less than 5, and I'll say sum plus equals x. So we'll add x onto sum every single time. And then the other thing that I'm going to do is I'm going to say var count equals 0. And what I'm going to do with count, actually, I don't need that. So x will count how many times this is going to loop through, because every single time it'll just increment by 1. But our loop will stop as soon as this is false, as soon as sum is not less than 5. Okay, and so down at the bottom here, after my loop, I'll go ahead and say alert x. And so we can see, you know, after we're done looping, I'll alert whatever x is, and that'll show me how many times we've looped through. So I'll come back over here, I'll refresh, put a breakpoint here, just so we can see what's going on. Is sum less than 5? Yes. So we'll add x onto sum, which will still be 0. And then x gets incremented, so now it's 1. We'll add 1 onto sum, and then we'll add 2 onto sum. X is currently 3, and so is sum. We'll add 3 onto sum, and then sum is equal to 6. And so if I let that go, you can see x ended up being 4 at the end of it. Okay, we looped through a total of 4 times. Get that. All right, so this is an example of a sentinel controlled loop, one that isn't just strictly counting, but it is dependent on a variable reaching a certain value or changing to something else. Okay, any questions on these two pieces of code? Okay, and let's look at some more examples. This is a for loop. Okay, now before you like throw your headphones off and quit, it's not as bad as you think. Okay, if I look back at my code here, you can see I'm declaring a variable var x. I'm just gonna go back to our first one, our nice simple loop. Okay, so you can see I'm doing several things here. Okay, let me blow this up a little bit. So var x equals 0, I declare x, and then I say while x is less than 5, I'll do something, and then at the end I'll make sure to increment x. Okay, now does anybody know what would happen if I didn't increment x right here? What do you guys think would happen?
Would it just stay the same?
Okay, so that's one thought. Amber, you said it would alert over and over again. So yeah, let's take that out and let's run it, and we'll see what this does. Okay, so I'm just gonna take out my breakpoint and I'm gonna run this. Page says 0, 1, oh, we're not incrementing, so it's just gonna stay at 0. Okay, so Shonda, you were right. It'll just stay the same. And notice that this is just gonna go on forever. And ever and ever and ever. Okay, and I actually have to close out of that tab because I would have no way of stopping that loop from executing. Okay, that is what we call an infinite loop. It's not a happy thing. Okay, so I bring that up though because there are 3 main parts of this while loop to make it work. Okay, I instantiate a variable, a condition for how many times I'm going to loop, and then have to change that variable to ensure that I'm not going to have an infinite loop. Okay, so 3 steps here. If I was going to write that exact same thing as a for loop, all right, a for loop basically does the same thing as a while loop. There's not a single condition that I could do something with a while loop that I couldn't do with a for loop, or vice versa. Okay, a lot of it comes down to preference. Some cases would be easier with one or the other, but if you never wanted to use a while loop, you never have to. If you never want to use a for loop, you never have to. Okay, to do this exact same thing, I could say for var x equals 0. Okay, while x is less than 5, x plus plus. And then I would alert x. These 2 pieces of code these 5 lines right here for my for loop, and these 3 lines right here for my, these 5 lines for my while loop, and these 3 lines for my for loop will do the exact same thing, okay? I have a variable being declared and set to 0. I have a condition for how many times I'm going to loop through, and then I have my variable that I'm going to change to make sure that my loop isn't infinite, okay? Now, the way that this code would execute, let me run this real quick. I'm going to comment this out so that we don't have it there. And then, oh, I closed my browser. That's right. Let me copy my file path. Ariana, glad you could make it. We're just talking about loops. That was enough to make her leave. All right, and then, so I'm going to stick a breakpoint right here, and let's run this, okay? So X currently is undefined, all right, but as soon as I hit F10 to go to my next step, okay, you can see it went over to my next step in my for loop, and now X is defined at 0, okay? Now it'll check to see if this is true. If it's true, just like with our while loop, it'll go into my loop, and it will run the code inside of my loop, okay? It alerted X. Now, look where I'm highlighted, right here. Okay, it'll say X++. We run that, it incremented, and then we run is X less than 5. Okay, and so the way that it runs is this gets declared once, and it will never get touched again. If this is equal to, if this is true, then everything inside the loop will run. Then it'll come up, increment, check the condition, run the code. Increment, check the condition, run the code. Increment, check the condition, run the code for as long as that condition is equal to true, okay? Any questions on this? Okay. Then let's head back over here. All right, so like I said, a shorter way to write a loop, all right? It's interesting to note that you actually don't have to have things in each of these 3 parameters, but you do have to have the 2 semicolons separating the 3 spaces inside of your for loop. So if for whatever reason, if I already had I declared, you know, if I was getting a value from the user or something like that, and I didn't have to declare it, I wouldn't have to, okay? But I do need the semicolon there so that it knows that, hey, this is the spot for my condition that will equate to a Boolean value to know if I should loop or not, and this will be where I increment. Likewise, if I wanted to, so if up here I said var x equals 20, I could take this out of here. And also, if down here I was like, you know what, I'm actually going to increment here for whatever reason, I could take this out as well. Okay, I still need both of these semicolons in there, otherwise I'm going to get a big error. All right, if I tried running it without, let me show you the error that I would get. Okay, you can see it's showing up in red right here, and in the console it shows unexpected token, a parenthesis. So it's saying this is unexpected because it was expecting several semicolons as soon as I said I'm going to do a for loop. Okay. All right. Now, it's not very common to see an empty for loop like this, but it is valid code if you're curious. Okay. You will also see a lot of the time people don't really put var here. They'll just say x equals 0. And that's valid too. It might not be as correct as if you said var, but that will work for you as well. Okay. Any questions on for loops? Do you recommend let or var for variables? I recommend whichever one makes the most sense for you. They both work. Yeah, good question, Michael. If you Google that, you know, if you Google, you know, in JavaScript, which is better, let or var, or JavaScript let versus var, you'll hear a lot of controversial opinions on that matter. Okay, and I'm just like, hey, they both work. So whatever floats your boat. All right, a for each loop causes the statement inside of it to be repeated once for each attribute in an object. Okay, now you may not know this, but you have worked with an object in JavaScript just about every week. All right, document in JavaScript is a built-in object that has all sorts of stuff in it. I know that because in JavaScript, the way that you access data inside of an object is by using a dot, okay? So let me open up my code again. I keep on closing my browser. Oh, no, I didn't. Okay, good. Let me refresh this. Did I fix it? Okay, I fixed it. I don't have document in there. Let me fix that real quick. So I'll say var x equals document.get element by ID. It's called integer box dot value. All right, I'll go ahead and leave that blank, and then I'll run this, refresh. So if I type in 50, I'm gonna put a breakpoint right here. All right. If I hit F10, you'll see X gets the value of 50 as a string. But look, if I hover over document, here's what I want to show you. These are all the different pieces of data that are inside of document. There's a lot here, okay? And I've showed you guys this before. It shouldn't be anything too new. Like I said before, most of this you'll never use, all right? But if I look in here, there will be a function called getElementById. And then if I hover over this, I can see everything inside of what that function gives me, okay? So this function getElementById is bringing me back a specific ID inside of my HTML. And that ID has a bunch of stuff in it as well. Now I have a JavaScript object representing that text box in my HTML, okay? And down here is value, which you have used like every week for the past few weeks, okay? And there's that number that the user typed in. So these are objects in JavaScript, okay? It is a way to store any amount of data in a single place for organizational and convenience purposes, okay? Now, back to the for each loop, okay? A for each loop allows me to traverse an object and look through every single item inside of an object. So right here, I say for var part in document, okay? Or if I wanted to read it like for each, I could say for part in each, or for each part in document, okay? And then I could do any piece of code, and then every time it finds a new item inside of that object, it will loop, regardless of how many are there. So let me open this up. So this will be kind of fun. All right, I'm gonna make a variable called message, and I'm gonna make it a string. And then I don't need an input from the user. Actually, you know what? We'll go ahead and keep an input. And I'll say, let me make this a little bit smaller. I'll say parse int. We'll make it a number so that the user can decide how many times they want to loop. So I'll go ahead and say, while x is greater than 0, and I'll say x minus minus. So what this will do, let's say the user typed in 50, I would loop through 50 times, okay? As long as x is greater than 0, okay? And then I'll subtract 1 from x every time I loop through. And then in here, actually, instead of that, let's do a for each loop. Sorry, guys, like I'm trying to teach you. I'm like all over the place. Okay, so I'll say var part in document. And then we will go ahead and say message plus equals part. All right, so let's say document has like 100 different items in it, okay? Each time I loop through, an item will be assigned to the variable part, okay? And so if I want to access like the 50th item, I would just loop through here, and then I could access it in part the 50th time that I loop through this. So I'm going to add part, whatever it is, to message. And then I'll go ahead and just say plus a line break. Okay, we'll see if that'll work for us. And then after my loop, I'll go ahead and say document.getElement by ID. And I have an output div here. I'll paste it there. .inner HTML equals message. All right, so it's coming to here. I'll take that off, refresh my page, and hit my button. Okay, so part currently is not defined because we haven't ran that code yet. Document is here with all of its stuff. Okay, now if I hover over part, it has location. Okay, and then I can assign that to message along with a new line character, and then I'll keep on looping through. Now it has implementation, new line. The next one is URL, new line. Okay, and I can loop through. Oh, it didn't do my new line. So let's try an HTML new line, see if that works for us. Okay, and there is all of our stuff. Pretty crazy, right? But loops are extremely powerful. There's a lot that you can do with them, and they're extremely helpful in many, many, many situations. Okay, any questions on this example? Okay, I'll go into this a little bit more to show you a little bit more that you can do with these loops and accessing data in them. You know what, actually, let me show you this real quick before I go on. So if I say part and add a colon, I'll take that out for a sec, plus document at index of part, okay? So I can also access the value of each thing. So in that list that just popped up, I saw like location, URL, different things. Those are what we call the key of a piece of data, and then each key has a value. And so right here, I'll access the key, whatever it's called, and then whatever the value is. Okay, so for example, our document.getElementById, value is the key, whatever the user types in is the value stored at that key. All right, so I'm going to say part is equal to whatever the value is, and then I'll put a break. All right, okay, so I'm going to put a breakpoint here just for a sec to show you. So I'm going to hit F10. So part is location, but document, if I say document at index of location, it'll find location in here, wherever location is, right here, all right? And it'll find that item inside of this object, okay? And it says, hey, this is what location looks like, all right? And this location looks like an object, and it has a bunch of stuff in here too. So it should be interesting to see what it prints up as, okay? But here's our location, all right? It just printed up something there, and then it looks like it said there was an object there, and then URL, compat mode, character set, char set, and you can see the value of each one of these things coming through. Okay, and you can see that JavaScript doesn't do very well with printing up an object. All right, it would do the same thing if in here without a loop I said, you know, message plus equals document. Oops. Document. Okay, if I tried that and remove that for a sec, you can see it's just like, hey, that's an object. I don't know how to print that unless you tell me how to print that, okay? But then as soon as I loop through an object, then I could assign each piece of that object to a string and print it out, okay? Any questions on this? You guys are sure quiet today. I hope my rambling is helpful. All right, a do while loop. This is the only post-test loop in JavaScript. So if I think about my for loop or my while loop or my for each loop, all of them had that keyword, either for or while, and then parentheses to check if it should loop through. The do while loop is kind of switched. It's kind of swapped, okay? So right here I say do this while a condition is true, okay? So this code, in other words, will always get executed at least once, regardless of the condition down here. And then down in this condition, if it's true, then it'll jump back up to the opening curly brace and it'll execute all of that code again for as many times as this code, as this equates to true, okay? When to use, when you can't use and must use a sentinel controlled loop, and where the statements have to be executed at least once before checking. Okay, let's look at an example for that one. We're in week 8. I don't have it there. That's okay. All right, so if I moved, let me make that a little bit smaller. So I'm gonna take out all my code here. And if I said do something, I could just say alert. Well, I'll just write this out actually so we can see what this looks like. Alias prompt. Do you guys remember what a prompt does? a prompt will be a little alert text box, a little pop-up with an input inside of it that I can assign to a variable in JavaScript. Okay, I'm going to declare these variables so that I can actually assign a value to it. And then for our second prompt, I'll say prompt, are you sure that the name that you put in is your name? Okay, and then so we'll execute this code once, but if this is true, then we will keep on executing it. Okay, and so here I'll just say, well, response is not equal to yes, and we'll loop it. Okay, so as soon as they say yes, my name is equal to what I said it was, then we'll stop looping. And then I'll go ahead and say alert hello plus alias, whatever name they put in. Okay, so let me copy this file. Well, I think I still have it open. Yeah, so I'll refresh, and I'll put a breakpoint right here. Okay, so I'll run this. Message is an empty string. Alias and response were declared, but they're still not defined. Okay, and then we have a prompt function being called. Pops this up. I'll say, oh, my name is James. Okay, James is assigned to alias. And then I'll have another prompt. Are you sure James is your name? I'll hit F10. Be like, actually, no, it's not. Okay, then response is actually, no, it's not. So I can check, is response not equal to yes? That's true. Okay, I didn't type in yes, I said, no, it's not. So I come up here, I'll loop through again. All right, back at the top of my do while loop. What's my name? I'll say Birch. And then it'll prompt my response. Are you sure Birch is your name? I'll say yes. And then it comes out of my loop because this was false. And then it'll let hello Birch. Okay. Any questions on the do while loop? Okay. No worries. All right. Different kinds of loops. So in each one of these columns, I have two examples that do the exact same thing. Okay. I have a while loop and a for loop in each, and each do the exact same thing. So you can see kind of basically what I showed you earlier, that you can use either one in just about any situation. It just kind of depends on your preference. Okay. So zero-based counting, we've looked at a couple of these examples. If I say n is equal to 3, I is equal to 0, while I is less than n, I'll alert leaf, and then I'll increment I. Okay, so how many times do you guys think this would loop? What do you guys think? What was that, Chanda?
3 times?
Yep, 3 times. Because if you think about it, I is equal to 0, so we loop through while I is equal to 0, 1, and 2, which is 3 times. Okay. Our for loop example, I have n declared up top, var I equals 0, while I is less than n, increment I, and alert leaf. So it does the exact same thing as our first one. All right, let's look at a skipping example. All right, let's say for whatever reason I didn't want to loop through every single number. Let's say I wanted to count by tens or by hundreds or whatever. All right, I could say var skip equals 2 or 10 or 100 or anything you wanted. Var n equals 0 and I, or n equals 12 and I is 0. While I is less than n, alert stem, and then we'll increment by skip, which is 2. So I is equal to 0, and for every single time we loop through this, I will jump up 2. So it'll jump up to 2, then 4, 6, 8, 10, and then 12. Okay. And I can do that exact same thing with a for loop. Instead of just having I plus plus over here, I would say I plus equals skip. Okay, and I do the same thing. And then an infinite loop. Okay, so we already looked at one example. In a while loop, if I didn't increment my number, that would give me an infinite loop because I would always be equal to 0. It wouldn't change. And so this would always be true. A for loop example, again, I don't know why you would ever not have something increment here, but it's possible, okay, to have an infinite for loop like that. A more common example of an infinite for loop, let me take this out. So if I said for I equals 0, while I is less than 10, I plus, okay, and then I could just say like alert I or whatever I want to do. you know? So this is a very simple loop. Okay, I'll loop through 10 times while I is equal to 0 up to 9. All right, but if I made a mistake here and I said, well, I is greater than 10, okay, that wouldn't loop at all, okay? That would loop 0 times, all right? But depending on what I do here, I can use any one of these operators that I said that we talked about last week in our if statements. Michael asked, would you ever want an infinite loop? No, never, unless you're a hacker and you want to break somebody's computer. Okay, and if we got into more security in this course, we would actually talk about that and how you know, there are different types of cyber attacks where they'll actually send data from a computer in an infinite loop, and they'll send requests to a server inside of an infinite loop. Yep, like a denial of service attack. Exactly. Yeah, they use infinite loops to do that, to just keep on going and going and going and going. And but outside of that, infinite loops they break things. So if you want to break things, then you can use an infinite loop. Otherwise, no, you would never want to use one. But yeah, so depending on this condition, I could also make an infinite loop there as well. So any questions on these, you guys? Any questions? Okay. Well, then let's keep going. So to get out of a loop, let's say I wanted to loop 1,000,000 times. Well, up to 1,000,000, but I didn't want to loop more than that. And I wanted my program to perform well. Anytime we talk about performance in programming, we're talking about the speed at which a program can execute a task, all right? So if I was going to loop through something 1,000,000 times, that would take maybe like a half a second. I don't know how long it would take depending on your processor. But it would take a certain amount of time. It'd be pretty quick. But the more times I loop through something, the longer something is going to take, okay? I'm not going to show you guys many examples of this right now, but you can have nested loops, okay? So if I had an object that had 100 items in it, like the document object that we saw, and I looped through every single one, but then inside of each one of those, I looped through something else, you know, to like check if it was equal to something or something, you know, that would multiply the number of times that code would be executed, okay, by having a nested loop. So there are times when you will want to, whoops, sorry guys, where you will want to get out of a loop, all right? This keyword break is how you do that. All right, so right here, imagine this loop. It says I equals 0. While it's less than 10, we'll increment I. The user enters a number, we'll assign that to n. If n is equal to 0, so if the user typed in 0, then we'll get out of our loop. All right, and then we'll get our sum, whatever the sum was, okay? So, you know, if I was checking for a certain condition or something like that, and I wanted to break out of my loop, or I have what I needed for my loop, if I was searching for a number, or something like that, and I reached that number that I was searching for, then I could just break out of my loop. I wouldn't have to keep looping, and I could use the break keyword. And that will immediately jump me out of my loop and then continue the execution of my code after the curly bracelet closed my loop. Okay. All right. Use cases and examples. So I have a couple here: computing compound interest, determining if a number is prime, and creating repetitive strings. So I already looked at repetitive strings. Okay, I showed you guys how I could use a for each loop to loop through document, okay, and make a massive string for that. But let's look at a couple of these examples. So string repetition, all right, notice I'm declaring my repetitive string. The last time I did it, I declared it as message. And then while I is less than or equal to user integer, if I is not equal to 0, we'll just add that onto my repetitive string. And I'll just have a comma delimited list of all these numbers. So if I ran this, if I typed in like 50 and ran the function, you can see I have 0 up to 50. Okay, because if I look at my code here, it says, well, I is less than or equal to user integer. So I typed in 50, it actually looped through 51 times because I declared I as 0. If I declared I as 1, let me go ahead and make that happen, and refreshed it and typed in 50. It's weird, it looks like it didn't update. But I could control how exactly I want I want to do this. Okay. Oh, it's because repetitive string started off at 0. That's why. Interesting. All right, so this is an example of having a repetitive string. Okay, and I could do anything I want with that. Later in this semester, I'll show you how to make like a multiplication, like a times table, using loops and using repetitive strings. But anyway, it's pretty cool stuff that you can do with that. Looking at compound interest, okay? So the user types in a balance and an annual rate, okay? So just a percentage, I could say like 4%, all right? I would get my monthly rate just by dividing my annual rate by 12, all right? And then for each month, I would compute the interest and add it to the balance, okay? So compound interest, if you're not familiar with that, it's just that your interest, so if I had like a balance of $100 and I had a 10% interest rate, you know, it would go up 10% in that given period of time. So it'd be up to $110. Well, my next period of time would get interest on that $110, not just $100. So my interest, instead of being $10, would be $11, okay? And then it would just keep on going up. So in this example, we have the monthly rate, while month equals 1, while month is less than or equal to the number of months. So the user could type in like 50 months or 60 months if they wanted to do like 5 years. We'll increment month, and then we will add balance times monthly rate onto our interest, and then we'll add that interest onto our balance, and we'll just keep on looping as many times as for whatever number that they put in. If I put this up in here, wow, sorry guys. I need to go through my programs. There's something funky that's been going on with them. All right, so let's say upstream balance. Well, it's just balance. I'll say it's $100. Annual growth rate we'll say is 10%, and number of months we'll say 60. Okay, your balance after 60 months will be that. Maybe it wanted a decimal there. Okay, that looks a little bit better. Okay. Okay, so you can see that after 60 months, I could get my compound interest value there. Okay, questions about this piece of code? Okay, let's look at our last one then. If I want to figure out if a number is a prime number or not, okay, if I had to say, so a prime number is any number that does not have any multiples other than 1 and itself. So 3 is a prime number because it is only divisible by 1 and 3. 5 is a prime number because it's only divisible by 1 and 5. 4 is not a prime number because it is divisible by 1, 2, and 4. Okay, so I could use a loop to see if a number is prime. If the user types in like 5017, I could check to see if that's a prime number. Okay, so the user types in a number, in this case 5017. Number of times looped, this is just here to count how many times we have to loop through to check to see if it's a prime number, just for kicks, right? And then factor count, we'll use that here in a sec. So divisor equals 1. Number of times looped, every single time we go through this, I'll just increment that so we can see how many times we looped. And then remainder equals candidate, 5017, modulus divisor. Okay, currently our divisor is 1, but we're going to increment divisor every single time we loop through this. Okay, so if I have 5017, it'll check to see if 1 is divisible by it, and then if 2 is divisible by it, or if it's divisible by 2, and then 3, and then 4. It'll keep on incrementing divisor to see if each one of those numbers, if any one of those numbers is a multiple of our candidate, 5017. And then if remainder is equal to 0, okay, because remember, modulus will get us the remainder of any division that takes place. So if I said 5 modulus 2, that would leave 1 left over. So I know that 2 isn't a multiple of 5, okay? So if remainder is equal to 0, it means we found a multiple, and I'll increment my factor count. All right, and then if I say if factor count is equal to 2, then it's prime, okay, because all numbers are divisible at least by 1 and themselves, okay, and then if it's anything else, which would be greater than 2, then it's not a prime number, okay. So let me copy this file path, and let's run it. All right, please enter an integer. If I put 5, I'll say 5 is prime. That pop-up right there is how many times it looped through. I alerted number of times looped. So it looped 5 times. If I type in 50, it looped 50 times, and then it says 50 is not prime. Okay. I could also, if we were interested, I could alert, instead of just saying this, I could say number of times looped, and then a period, and then factor count is exactly how many factors a number has. So I'll go ahead and refresh this. If I type in 50, you can see number of times looped, oh, whoops, and then factor count is 6. Okay, it looks like I have an error in here. I just need to put this outside of the string. So I'm going to close that, add that as a variable, and then continue my string. So I refresh. If I type in 50, I have an error going on in here. There we go. That was weird. All right. It says number of times looped 50 and factor count is 6. Okay. If I loop through 6 times, or if I put a 6 in there, you can see I looped 6 times and factor count was 4. All right. And then it says 6 is not prime. All right. And then I can try out my 5017 number and says we looped 5017 times and it's not a prime number. It had a factor count of 4. Okay. And so in here, if I wanted to, I could also, I could save those variables somewhere else or save those numbers. I could see what factors those were if I wanted to. But okay, so I loop through every single time for a number to see if it was prime or not. All right. This does it. It gets the job done. We could see if any number is a prime. All right. If I wanted to check 1 million, see how long it takes. That's pretty quick. Okay. Looks like it has 49 factors. Who knew? Okay. Now let's look at our fast example. Okay. So I have a function called isPrime. Again, the user types in a number, same thing. And then I have a limit variable here, which gets the square root of candidate. All right. If you think about it, if I have the number 5, okay. Well, let's think about 6 because it's even. That might be easier. As soon as I find that 6 is divisible by 2 and 3, I don't have to continue checking to see that like by 3 and by 2 or something like that. If I had 10, as soon as I hit 5, I know the first half of my multiples. Okay, I know that 10 is divisible by 1, 2, and 5, and so I don't have to keep on looping to see that it's divisible by itself as well. Or if I have 20, and so if I just get the square root of it, then it will give me a limit, so it'll automatically make it so I have to loop half the number of times. Okay, but then I say var prime equals true, number of times looped again. Remainder, this is the exact same thing as last one. If remainder is equal to 0, prime equals false, and break. So as soon as I come across my first one, okay, notice divisor is 2, so it's not going to start with 1. But as soon as I find a match, okay, something that's divisible by the number that's greater than 1, I'll set prime to false, and I'll break out of this loop. Okay. So let's run this and see how many times it takes to loop through our number. So if I type in 5017, number of times looped is 5017. Oh, it's the wrong program. Let's see if this works. Okay, good. So I don't know if you guys have heard of GitHub. You guys are never going to want to touch it after seeing how I messed up all my stuff. It's a code version control program, and anytime it found, like the last time I tried to update my code from my other version, it found that that there was an error in the match, and somehow it wrote all that stuff into my files. Okay, so the number of times looped was 1. Okay, and if I think through that, it's because my divisor is 2, which means the first time I looped, candidate modulus divisor was equal to 0. 50 modulus 2 was equal to 0. And so it broke out of my loop immediately. All right, let me grab this just so we can see this in our alert. All right, refresh this. I'll type in 5017 and run it. We didn't have our alert. Oh, factor count is not defined. This is good that I'm showing you guys these errors because they're really common errors that people see. So it said factor count isn't defined, and it's because I'm not counting the factors, okay? Right here, I just say prime is equal to false as soon as I find the first factor. I'm going to take this out. Oops. Refresh. So 5017, we loop through 28 times to find our first match, okay? And then if I look at 1 million, I have a feeling it's going to be once. Yep, it was a multiple of 1 million, okay? So 2 different ways to do it. One is a lot more efficient for 2 different reasons, okay? One, we're only going to loop through half the numbers, worst case scenario. And then 2, as soon as we find our first evidence that it's not a prime number, then we break out of our loop, okay? All right, any questions on any of these, you guys? Okay, well then, let me see if I have anything else for you today. Common mistakes, this is my last thing. So writing infinite loops, we kind of already talked about that. In this example, the programmer just forgot to increment I. So I would always be equal to 0. A loop that never repeats, okay? I equals 0 while I is greater than 3, I plus plus. That will never happen because I will never be greater than 3, so the code won't get executed, so we won't increment I. Okay, might as well just not even have a loop. Won't do a thing. Using commas instead of semicolons. Okay, this will throw you a big error. All right, let me show you what that will do. Remember that error that I showed you where I didn't put a semicolon? And it's like, hey, unexpected parenthesis. Let's look at what this will do. I have an error in here and it says, unexpected token, this less than or equal to sign. Okay, it didn't expect that because I didn't have a semicolon. Okay, I declared this, which was fine. And it was expecting me to declare something else. If I really wanted to, I could say x equals 5 and then a semicolon. And this would be valid code, okay? If you wanted to declare something inside of your loop, you could do that, okay? But not very common. All right. Next one, forgetting braces. All right, these curly braces here are really important. Some programming languages know how much to loop or how to use if statements and things like that by the indentation, how far indented it is. JavaScript, I could put this entire thing onto one line of code and it would work just fine. Let me show you real quick. Control-Shift-L. Okay, so it's all on a single line of code. You can see this is line 18. All right, and if I run this, oh, we do have an error. Unexpected end of input. I think it was because I forgot to fix that for loop. But I can run all this JavaScript on a single line of code. It doesn't care about indentations or anything like that, okay? What it cares about is these curly braces. So that's how the code knows how many times it's gonna run, just by those, or what code is gonna get repeated, just by having those curly braces there. And then another one, placing semicolons after the parentheses of a loop. All right, so does anybody want to guess what would happen here if I had a loop and then I put a semicolon right there? What do you guys think? So ugly to look at. Yeah, that's called minified JavaScript, okay? Performance-wise, it technically runs faster than having all the line breaks in there, but anytime you push a piece of code to a production website, it'll just about always be in a minified version of JavaScript. Almost every company that I know of does that. Let's actually see that real quick. So if I opened up, let's say Google Drive and hit F12 and looked at my sources, look at all this stuff in here. JavaScript, look at that. Talk about hideous, right? That's JavaScript. That's the same thing that you guys are learning right now. It's just minified. See how it's like all in the same, looks like they have 12 lines. Okay, so you know, they went above and beyond with their minification, but But yeah, so that's minify JavaScript for you. If I put a semicolon at the end of a loop, okay, let me undo that and put a semicolon right there and run this. Okay, notice I don't have any errors, nothing showing up in my console, everything looks fine. And then I type in this, or I click that and it says, uncut syntax error, illegal break statement. Okay, break is only legal if it is inside of a loop. Otherwise, it's illegal. Okay, it's used inside of loops. That's it. Okay, so as soon as I put this break here, it's like, hey, I'm not inside of a for loop, even though I have these curly braces here. Okay, this in effect ended my for loop. I might as well just not have it. Okay, and so this break there caused an error. If I didn't have that break and refreshed and ran it, you can see it says it looped through once because all of this code was executed. All right, but once I reached this, it didn't loop at all. It would just keep going, okay, because I ended my for loop statement. All right, so that is that one for you guys. And then use the developer tools. You guys, look how many times I've used these tools today, okay? It's so huge, okay? So I know I talk about this like every week, but please, 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 when you're writing your code, use your developer tools, have it open. If a funky error pops up because you had a semicolon there, it'll show you. Michael said, love using it for dates. You can change the date on the fly. Yeah, seriously. So let me show you that example. So week 7, let's see here. Check to see if I can sleep in, okay? So if I run this real quick, now this is just a happy stint on developer tools. So F12, I open this thing up. I can blow this up because I'm not really gonna have anything on the page. I'm gonna put a breakpoint right here, okay? Set today's date, okay? Here's my date, nice beautiful date object, okay? Day of the month, all right? If I wanted to change this, I can even make changes like inside of my code right here, okay? And you know, I can make any change that I want to. I can assign other values. There's a lot of different things that you can do with your developer tools. So please leave these open. If you're not super comfortable with debugging, in the video spreadsheet there, I have a video dedicated to using these developer tools, and one of them basically just on debugging. These 3 over here. Okay, so one is for the Elements tab, one is for the Console tab, and then the Sources tab is where I talk about debugging. So anyways, you guys, I feel like I've been rambling for like an hour straight. You guys are so quiet. But I hope that this was helpful in learning about repetition. I seriously love loops and everything like that. It's super powerful. You know, like when we saw every single item and document just like pop up on the page like that, it just blows my mind, you know. So they're really cool. I hope that you guys enjoy your assignments this week. And if you do enjoy your assignments this week, then you know that you're in the right field, okay? Because only a nerd would enjoy something like repetition. So, all right, well, any questions before I let y'all go? Was fun, but a little difficult with the logic. Okay, yeah, and it'll take some practicing. Remember what I said at the beginning of class, okay? If I look at a simple example, let me go back to a while loop here. Where'd that go? While loop. Okay, this is basically like an if statement. Okay, if you think about your if statement, you're just like, if x is less than 5, execute this code inside of my curly braces. It's the exact same thing with a while loop. Okay, while x is less than 5, execute it. The only difference is we're incrementing x, and we'll keep on executing it as long as it's true. Okay, so that's why we cover repetition after the logic chapter, just because that's how we decide if it's going to loop or not, because it still equates to that Boolean value. Okay, it does get a little bit more difficult looking when you look at the for loop. Okay, and if I go to our example of different types of loops, you know, so these will do the exact same thing. You know, the for loop is just like a shortcut for how to do it. You know, I can declare I in the same line, I can increment I in this same line, and then it'll just kind of go in a circle from checking the expression, running the code in the loop, incrementing I. Checking the expression, running the loop, incrementing I. You know, it's just a shorter way to write it. But practice will help. Running through those examples in the book will help. And then doing your assignments. So, but hang in there, you guys. But all right, any other comments or any questions that you guys have? All right, well, you guys have a wonderful week, and just shoot me an email if I can ever help you with anything. Okay, thank you, Shonda. Have a good day, guys.